All right. So this is actually going to be the last lesson we do in this chapter, at least in the year that I'm recording this, because we're not gonna do congruence transformations or coordinate proof, and all of that. So this is going to be it. We're fast approaching test time, and so we're going to talk about isosceles triangles, equilateral triangles. We're going to learn some theorems. We're going to do a quick example, and then we're going to be done. This is a nice chapter. You got to admit it. This is an easy one. Easier maybe is a better phrasing. So isosceles triangles, what are they? We've talked about that before. So the definition of an isosceles triangle is a triangle with two congruent sides, right? So something like this guy. So there is a theorem associated with isosceles triangles. We've kind of talked about it before in passing. We're kind of putting some for sure meat on it, and that says that the base angles of isosceles triangles are congruent. Okay, so what are we talking about base angles? So we're talking about the angles that, if we even if we took, let me kind of grab this and make another version of the same thing down here, and even if we took and flip this around like that. So the base angles are the ones that if we kind of draw lines down from the congruent sides, those are the base angles. So like in this case, it'd be these angles right here. Now, also if we flip it around, still the isosceles, if we draw kind of arrows from the congruent sides down to some angles, those would be the base angles. So this theorem says that if you have an isosceles triangles, its base angles are also congruent, right? Which is great. You might also know that. Now, I also put this note in here so I would remember to talk about it, that the converse of this theorem also exists, and that says that if two base angles of a triangle are congruent, then the triangle is isosceles. So we can use it to prove that a triangle is isosceles as well, right? So those are the theorems there. Now we also have equilateral triangles. So equilateral triangle, there's an equilateral theorem, triangle theorem that's associated with it. And it says that a triangle is equilateral if and only if it is equiangular. Angular. Right? Okay, so we've seen equiangular. So what does equiangular mean? So it says that all three angles are congruent. And so the only way the triangle can be equilateral is if it's also equiangular. So if all these angles are equal, then this triangle is equilateral, right? Let's see. Let me make sure. So one of the things that is kind of I would call it a corollary. Actually, both of these are corollaries to some other theorems about equilateral triangles and actually isosceles triangles as well, and that is simply that all the angles add up to, or not add up, all the angles are 60 degrees, and I'm not even going to write that formally out, right? And the reason why we get that is because we already know that all of the angles inside of a equilateral triangle, equiangular triangle, are of any triangle add up to 180, and if they're all the same, 180 divided by 3 is 60, right? And so that's how we get that and that corollary there. So there's the definitions, there's the words. Let's do an example and then let's leave and be done with this lesson and chapter and whatever else, and then we'll get on to the big, giant, huge vocabulary lesson soon. So we want to find, I forgot to write the instructions, so we'll write them now. We want to find the value of each variable. So we're finding X and we're finding Y. So let's take a look and see if we can kind of figure out what's going on here. So for sure, because we are told so, that AC is congruent to AB. We got these tick marks on there and all that kind of stuff is true, right? And so we know, let's kind of start labeling stuff that we can figure out. We know that this is 3, right? We also, so this is an isosceles triangle for sure. And these would be base angles. So this is congruent to this. Wait a minute. Wait just 1 minute. I'm going to do that a little bigger so we can still see what's going on here. That's 2x and that's 2x. If these two base angles are congruent, then that means this triangle is an isosceles triangle in this direction as well. So this side is congruent to this side, which means if this one's congruent to this one and this one's congruent to that one, then by the transitive property, these are congruent to this one. So this is not just a isosceles triangle. This is, in fact, an equilateral triangle. Look at that. Look at us mathing, right? So that means each one of these is 60. So 2x would equal 60. And these sides are the same. So 4y, ooh, what is that ugliness? 4y minus 5 equals 3, right? So we've got equations. Let's do them. Let's solve them. They're easy peasy. This one we're going to divide by 2. And we're going to discover that x, in fact, equals 30. Bam. Then this one's also easy peasy. We'll add 5 to both sides. That's gone away. And then we've got 4y equals 8. And then we can divide by 4. That's gone away. So y equals 2. Done. Done. Finished. That's it. Put that one in the books. If you're one of my students, do your homework, see you in class, study for your test, all the things. If you're not one of my students, thanks for joining us. Hopefully this was useful to you. Let us know how else we can help you with math or science or homeschooling in general. Have a fan-flippin' tabulous day. Bye-bye.